In this video lesson, we're going to be able to define percent composition and calculate the percent composition of several compounds. To get started, let's first determine how you figure out what percent composition is. Your first step is to determine the molar mass of the compound that you are given. Once you determine the molar mass, step 2 tells you to divide the mass of the individual element by the molar mass of the entire compound. Essentially, what you are doing in step 2 is you're doing a part divided by whole ratio. The part represents the part that you're interested in, whereas the whole represents the entire thing, whether that's a compound or an element. In step 3, you'll multiply your answer in step 2 by 100 to simply turn it into a percent. Now that we know these steps, let's go ahead and take a look at a few examples. Suppose I gave you the compound H2O, or water, and asked you to determine the percent composition. Essentially, what I'm asking you is what percentage of that compound is hydrogen and what percentage of that compound is oxygen. In order to do that, let's go ahead and walk through our steps. Our first step is to determine the molar mass of our compound. The compound we are looking at is H2O. For hydrogen, the atomic mass of one hydrogen is 1.01, and the atomic mass for one oxygen is 16. Now, since we have two hydrogens, I'm going to multiply that by 2 to give me a total mass of hydrogen of 2.02. Since there's only one oxygen, I'll multiply that by 1 to get 16 for the mass of oxygen. As I add those together, my total molar mass is 18.02 grams per mole. This is the molar mass of my entire compound, which is step 1. Now, step 2 tells me to take the mass of the individual element and divide it by the mass of the entire compound, or the molar mass. Since this problem does not ask specifically for hydrogen or specifically for oxygen, we're going to go ahead and do them both. Let's first do hydrogen. The mass of hydrogen we found in the first step. It is 2.02. Therefore, I will take 2.02 and I will divide that by the mass of the entire compound, 18.02. If I take those two numbers and I divide them, I get approximately 0.112 as my fraction. My final step is to take that number and multiply by 100 to turn it into a percent. 0.112 times 100 equals 11.2%. What that means is that out of our compound water, 11.2% of it is hydrogen. Now that was for hydrogen. Let's go back and do it for oxygen. Step 1 is going to be the same. We still have the same molar mass because we're working with the same compound. The steps change, however, when you get to 2 and 3. In step 2, we only did the percent for hydrogen. Let's now do it for oxygen. Since we're looking at oxygen now, we're going to use the molar mass or atomic mass for the oxygen part, which is 16. Now, when I put on the bottom, I'm still going to put the molar mass of the entire compound, 18.02. When I divide those two numbers, I get approximately 0.888. That is my fraction for oxygen in this compound. My final step in step 3 is to take that answer and multiply it by 100 to get my percent. My percentage is 88.8% for oxygen. Now notice something. Notice how there are two answers that we got, 11.2 and 88.8, add up to be 100%. That is a good way to check to make sure you've done the problem right. All your percentages should add up to be 100%. Let's take a look at another example. Consider the following compound, AlCl3, aluminum chloride. Let's go ahead and figure out the percent composition for this compound. Our first step is to determine what is the molar mass for this compound. We have Al and Cl. Al is 26.98, and there's only one atom, leaving it at 26.98. Chlorine is 35.45, and there are 3 of them. That gives me a total of 106.35. Adding those together will give me my molar mass for aluminum chloride. In this example, the molar mass is 133.33 grams per mole. Now when we go to step 2, now we can figure out the individual percentages. Let's do aluminum first. Aluminum is 26.98 of the total. That's what goes on top. On the bottom goes the molar mass. We determined that was 133.33. When you divide those two answers, you get approximately 2.202 as your fraction. By multiplying that by 100, we get our percent. In this case, our percentage is 20.2%. Now we have to do the chlorines. Now the chlorine can be calculated in one of 2 ways. Either A, we can do what we did in steps 2 and 3 to determine what the percentage of chlorine would be, or we can use this reasoning. We know the total percentage of this compound has to be 100%. If you know the total has to be 100%, and you know the aluminum part is 20.2%, we can simply subtract those two and get the percentage of what the other part, in this case the chlorine, should be. If we take 100 minus 20.2, the percentage for chlorine then must be 79.8%. Both steps can be used in determining percent composition. As a practice, go ahead and try these 3 now. Pause the video, then hit play to reveal the answers for each problem. For the first one, hydrogen has a percent composition of approximately 2.06%. Sulfur has a percent composition of approximately 32.69%. And oxygen has a percent composition of approximately 65.25%. Notice how my percentages include 2 decimal places. Yours might include 1 decimal place or may have been rounded even further. As long as your answers are in the general range, that is okay. For the second one, carbon has a percent composition of approximately 74.83%, whereas hydrogen has a percent composition of 25.17%. Finally, for the last one, notice how there's 2 nitrogens in this compound. Those can be included in the exact same percentage since they're the same element. Therefore, nitrogen takes up approximately 35.00%, hydrogen takes up approximately 5.05%, and oxygen takes up approximately 59.96%. This concludes the video on percent composition.